Greetings. I'm going to do a short lecture to finish up the lecture on LLParsing. This is the grammar that we constructed an LLParse table for last time. So I just wanted to show you that grammar in JFlap. So here is JFlap, and I'll make that a little bit bigger. Here's the same grammar. In JFlap, you can click on the input and select Build LL1 Parser. You can then enter in the first and follow sets. I'm not going to do that because we already did it. So I'm just going to get it to go ahead and show there's the first sets and there's the follow sets. And then you can also enter in the entries for the table, the parse table. And again, we did that last time, so I'm not going to do that. I'm just going to show you there. And then what we want to do now is go ahead and parse a string. So here again is the table, so you can see that. Here is the grammar, and we are going to pick a string, and this string I'm going to use is A, B, C, A, C, B, A, B, C, A, C, B, and I think we can make that a little bigger too. Whoops. There we go. Okay, so I'm going to parse this now. So if I parse it using the table, we'll start. It's just going to put the string plus the $sign on the input remaining. We're going to step through, and the first thing that happens is we put the S on the stack, so you can see that. And then what we're going to do is the next step is we're going to look in the table under SA, because A is the first input string. And under SA, you'll see ACB. So if I click step, you'll see the ACB is highlighted, and we're going to, the S is off the stack, and then we're going to push on the ACB. So you'll see ACB is pushed onto the stack, where A is the top of the stack. And then we'll do another step. So we're going to have capital A and little a. If you look up capital A, little a in the table, you'll see AAB. And that A gets popped off and then gets replaced with the AAB. There they are. At the same time below, you can see the parse tree is building. We keep going. Now there's two A's. A terminal A is on the stack, so we're just going to pop it off and match it with the symbol. So now we lose one of the input remainings. Now we have AB. AB says replace the A with lambda, so A has been popped off. Next we have two B's, so they're going to match. They both get popped off the stack, and we process the little b, terminal B, and the input remaining. We have two C's. They're gone. Now we have capital B on the stack and little a on the input. So we are going to look in the table under BA. B gets popped off the stack. We replace it with ABB. There we go. And then we have two A's on the stack, so they're gone. Sorry, A on the stack and A in the input remaining. They both are gone now. We have capital B on the stack, variable B. We look up BC, and we see that is pop B off and replace it with little c. So B is gone. We replace it with C. Now we have C on the stack, terminal, and C input string, input symbol. They're both gone. We have B terminal on the stack and B input symbol. Those are gone. And so now we just have $sign and an empty stack, and you can see at the very bottom it says string successfully parsed. So that's an example of parsing with the LLParse table. Let's go back to the notes now. There we go. And let's look at another example. So now we want to build this table here. And let me put in here, we'll put the variables here, S, A, and B. Now if we start building this table, there's no lambda, so this is going to be easy to do. We want to know like where to use the S rule. S goes to ACB. So we would get the follow of capital A, sorry, the first of capital A, which is just little a. So we would use, oh, I see. First we have to do the first and follow sets. Sorry, let me do this here. So this is just A, A. These are all very easy. because there's no lambda. Follow is $, C and B and $. Okay, now let's do the table, S, A and B. All right, so now where do we use the S goes to ACB? There's only one S rule. We do the first of ACB and we're just going to get A, so this is going to be used here, ACB. Now this is where it gets interesting. Where do we use the first A rule, which is A goes to AAB? Well, first of that is little a, so we're going to put it under little A, B. And then we go to use the next rule. A goes to little AB, and that's also, the first of that is also A, so we're going to put that in there. That means our grammar is not LL1. We have a conflict. When we see an A, we don't know which of the two rules to use. And if you continue this with the B rules, you'll also see there's a conflict on the A. So you're going to get A, B, B as one possibility when B is on the stack and little a is the next symbol. And you're also going to get ACB. So that's a problem because we don't know which rule to use. Now, what we could do is look at two look-aheads instead. So if we look at two look-aheads, I've already built that table. Here's the LL2 parse table. So the K value, 2, is how many look-aheads you're looking at. And if we do that and build the table, then we don't get any conflicts. So this is actually, this grammar is an LL2 grammar. That means we can use two look-aheads and we can build a table that has no conflicts. Okay. Here's an example of actually parsing a string. So I'm always showing two look-aheads in the symbol at the bottom. So we'll look at two look-aheads. AA, and we have S on the stack. So we'll look in here, when you see S and AA, you use ACB. So the S gets popped off and the ACB gets put on. Then we still have those two A's as look ahead, and capital A is on the stack. And that's where you can see that we know to use AAB rule, not the AB rule. And so here, the capital A gets popped off and we replace it with AAB. Our look ahead is still AA, but now when that A gets popped off, then we pop off the A, and now we have, in the next thing, we have capital A with look ahead AB. And if you look in the table for AAB, now we're going to use the rule A goes to AB, and sure enough, A gets replaced with AB. Now next time the A gets processed off, and then we have BB as the look ahead. When BB is the look ahead and capital B is the rule. Oh, wait a minute. Sorry, BB. We're going to, there we're going to have terminal. So terminal pops off, another B pops off, another B pops off, and then we have a C pops off, a C pops off. And finally we get down to a variable. So we have variable B and the look ahead is AC. Now we look in the table. For variable B, look ahead AC, we use B goes to little a, little c, little b. And that's sure enough what we do. B gets popped and you put on ACB. AC is the look ahead and it goes on and on. So I'm not going to finish it. Okay, but that's an idea of how you would parse if you had two look aheads. Here's another example and a grammar for this one. So this is strings where you have any number of A's, or if you have a B, it has to have the same number of B's as A's, and all the B's follow the A's. So here's a tricky thing now, because we need to determine when we see an A, or 3 A's, or 4 A's, which rule do we use? Do we use S goes to A, which essentially generates an A string, or do we use S goes to B, which generates a string of A's with an equal number of B's following it? So this is actually pretty tough because you don't know if you're going to have 1,000 A's, then you would need at least, and then 1 B, then you would need 1,001 look aheads. But if you had a million A's, you would need a million look-aheads, 1,000,001, to determine if there's one more character. Is it $, or is it a B? So it turns out that this language, or this grammar, is not LL1 for it's not LLK for any K. So this one, we can say this is not LLK for any K. So you basically can't use any kind of LL parser for this grammar. All right, we'll look at another one here. So I'm not showing you the grammar for this, but you can imagine it. This one has strings of A's, 0 to 10 A's. It also has strings that have 0 to 10 A's followed by an equal number of B's. So it's kind of similar to the one above. You can kind of imagine the grammar. What is the K for this one? So the biggest A string is 10 A's, and then you either have a $, or a B. So that means this one must be LL11. So you either have a $10 or A10B, and then you would know, do you generate a string of A's versus a string of B's? You need at least 11 look-aheads. Let's look at one more. Here is one more grammar. So now we need to figure out what is the K for this. What is the K? Okay. So we need to determine which S rule to use. We could also determine which B rule to use, because there's 2 B rules, and which C rule to use, because there's 2 C rules. And then whichever one has the largest number of look-aheads is what the grammar is going to be. Let's just focus on the S rules. So what is the biggest string that you would have where you need, so you can determine how many look-aheads? So for this S goes to B, B, C, D, you could have any number of C's replacing that C. And if you look at the second rule, you have a B, which could have any number of B's followed by 2 C's. So the similarity between those 2 rules is going to be B, B, C, C. You could generate that with either one, and then in the left rule, you could follow it with a D. In the other rule, you could follow it with a $. So in order to determine which S rule, you need 5 look-aheads. So K equals 5. To determine which S rule to use. That's going to be bigger than the B rules or the C rules. And that is it for it. So this is a short lecture. Hope you get a nice break.